So this is an interesting problem because this one actually doesn't give any numbers. It just asks what is the final velocity if you have a block at rest and then you let it go and then it goes all the way to the ground. And they just want the final velocity and they don't give you any numbers. So how you do this problem is just you start off with the concepts. So you have to understand that energy is always conserved. So E1 will equal E2, and then E1 is composed of kinetic and potential energy, and then it will equal the final kinetic and potential energy. So if this block starts at rest, that means that kinetic energy will be 0, and if it goes all the way to the ground, then potential energy will be 0 for the final. So we can therefore get rid of the kinetic initial and potential final, right? Because at the beginning it's not moving, so therefore it will only be potential energy because it's off the ground. And over here, the potential energy will be 0 because if it's on the ground, then it has no potential energy. So it will be initial potential energy is equal to final kinetic energy. And so the formulas for each are mgh and 1/2 mv squared. So since we have mass on both sides, we can cancel it out, because if we divide each side by mass, the masses would cancel. So we're left with gh equals 1/2 v squared. And so we want this v, right, because it's the final velocity. So what will we do? Well, we can multiply each side by 2. So we'll get 2gh. And then since it's v squared, we can square it. And then we'll end up getting square root of 2gh is equal to v final. And that's your final answer for this problem. And so this was interesting because it didn't give you any numbers, but you can still figure it out if you know the concepts. I hope that helped, and thanks for watching.